All right, some more examples coming your way for verifying trig identities. Just a couple more complicated ones coming up here. First thing, I'm going to look at this one. More complex side is the left-hand side, so that's what I'm going to work with. I'm going to notice immediately I have something squared with a 1 up on the top, so that's where I'm going to start right away. The other thing I'm going to notice is my numerator here has something squared with a 1. So I'm thinking Pythagorean identity right away because of that secant squared minus 1. Secant squared minus 1, the identity, as you look at your sheet, would be just equal to tangent squared of theta. So I can adjust my numerator like so. At this point, I could look, maybe I could change secant squared using Pythagorean. I could say, well, secant squared is equal to 1 plus tangent squared, but that really doesn't help me much because I don't have a denominator. Something should be able to cancel out in my denominator. So with that in mind, I'm going to try to find a way to separate these in another fashion. Well, what I'm going to do here is just to make it look easy, I'm going to call these both tangent on top and both secant on the bottom. Tangent, then I can rewrite, well, if all else fails, let's turn them into sine and cosine, especially when I want something as an answer that is just sine. So tangent can become sine theta over cosine theta in both aspects. And down here on the bottom, secant theta is the same as 1 over cosine. So if it's secant on the bottom, that means it would be cosine on the top. So these are really cosine theta over 1s. That's turning tangent into sine over cosine and turning the secant into cosine on top. Well, as you probably noticed right away, I got cosines on top and bottom that cancel out. I'm left with just sine times sine, which is sine squared of theta, which is exactly what I was looking for. So again, just an example of when all else fails, change everything into sine and cosine. Here's another example. More complex side is here on the right-hand side because of the fact that you have two different terms. Okay, I'm going to recommend on this one and on the next example, pause after every step or before every step. See if you can match what I'm trying to do with each one of these problems. And when you get stuck, go ahead and hit play again and see if you can catch up. So the first step I'm looking at here, more complex side, so I'm going on the right. There's no Pythagorean identities, there's no basic algebra. So when all else fails, I'm going to turn things into sine and cosine. Now, what might be interesting here is to note that, hey, I do have a cosecant, so maybe I don't want to change that cosecant. Well, if the answer had cosecant on top, I might consider keeping it like that. Because cosecant's on the bottom, yeah, I'm going to flip things around. I'm going to call this, instead of cosecant, it'll be sine on the bottom. And then we've seen a couple examples like this. You have two fractions that I need to get combined into one fraction. The easiest way to do that, well, really the only way to do that, is to make a common denominator. So we're going to have sine of t and sine of t as your multiplication. So this part here, you still have 1 over sine for the first, and then this is now going to become sine times sine, which is sine squared over sine. So now I can combine those into the one fraction. And light bulbs should be going off big time at this point, because you see right here you have something, 1 and a trig function squared. You should be thinking immediately that that is a trig identity. 1 minus sine squared is cosine squared. So I have cosine squared of t, and I mean we're changing the variables around, t, alpha, theta, beta, everything. But there you go, you have cosine squared over sine. Okay, from here, this might be one of the more complicated ones that we've gotten to. Because what I can do here is, I need to kind of look at what I'm trying to get to. I need to get to a cotangent squared. I only have cosine squared. Well, cotangent is cosine over sine, which technically I have. If I split this up into cosine t times itself, this part right here is going to be equal to cotangent. So that part just becomes cotangent of t, but I still have cosine of t. So somehow I need to figure out how I can get another cotangent and then cosecant on the bottom. Well, here's a little trick that you can use. We've kind of done it already actually in this problem. I can multiply by anything as long as it doesn't change the context of the problem. What I mean by that is I'm like multiplying here by a big number 1. Sine over sine doesn't change the problem. I can do that same idea right here, I need another cotangent, which means I would need sine on the bottom, because cosine over sine would give you cotangent. Well, if I multiply by sine on the bottom, I better multiply by sine on the top. So I run out of room, I'm going to bring this over here. So right now I still have the cotangent of t. Cosine over sine becomes another cotangent of t. And then I still have this last part, this times sine of t. So cotangent times sine as I squeeze all that in there. That's what I have still. Well, cotangent times cotangent, pretty straightforward. That becomes cotangent squared of t. Well, what do we need to find? We need it to be cosecant on the bottom. Well, sine on top is the same as cosecant on the bottom. So that's what you wanted to get. That's what we were looking for. You get your check mark. Okay? That's one of the tougher ones that we've done so far, because you kind of need to intuitively look at one of those. That would be like, say, a bonus type problem on an upcoming test type situation. And again, there are multiple other ways to do this. You may have been able to do it without having to go that route, depending on how you started the problem. Okay, one more good one. Again, I suggest you pause the video when you need to, pause it ahead of time, see if you can work one step ahead of me. Okay, so starting on the left-hand side, more complex, more terms. I'm going to make a common denominator. So 1 plus cosine on top and bottom over here, and 1 minus cosine top and bottom over here. Just basic algebra on one side of an equation, working just with the expression over here. So you have 1 plus cosine of theta, and 1 minus cosine of theta is what will be on top. Your denominator is then multiplied. 1 minus cosine and 1 plus cosine. On the top, the cosines are going to cancel out. I'll just be left with 2. Well, that's good. That's what I wanted. On the bottom, if I FOIL this out, 1 plus cosine minus cosine, and then minus cosine squared. Show every step, the cosines will cancel out. You get 1 plus, actually not plus, you'll get minus cosine squared theta. And again, light bulbs, 1 minus cosine squared ought to be a trig identity. It is. 1 minus cosine squared is equal to sine squared, which is exactly what we wanted. 2 on top, sine squared on the bottom, and there you have it. Couple complex ones coming up in the next video.